Good morning. This is Dr. Yogesh Agrawal, Associate Professor, Sagar Institute of Research and Technology, Bhopal. Today I will discuss the topic multi-stage compressor and the performance of the air compressor. Before going on the main slide, today I will discuss about the outline, multi-stage compression, two-stage compression without intercooling, two-stage compression with intercooling, performance of the air compressor, how to increase isothermal efficiency. This is the today outline. This is the multi-stage. It is called also two-stage reciprocating air compression, where the compression it is done more than one stage. That is called a multi-stage. Here the PV diagram is depicting on the two-stage compression process, low pressure compressor and the high pressure compressor. They are used to generate high pressurized air. They have one low pressure compressor and the one high pressure compressor, and in between there is a intercooler for the cooling of the air. It is taking place in the intercooler. Firstly, air goes into the low pressure compressor and the compress. Then this is compressed air goes into the intercooler, where it is called a heat exchanger, where its temperature will be down and by rejection of the heat at a constant pressure. So this is the low pressure compression. This is the depicted in the figure. 1 to 2 is the process, polytropic process. 2 to 2 dash, that is called a intercooling, and 2 dash to 3, that is called a high pressure compression. So this is the pressure condition where the compression is starting taking place. Pressure P1, P2 is the where the intercooling is done, and the P3 is the pressure where the final delivery of the air is taking place at the discharge side or the desired place. So this is the diagram where the compression it is done. First stage, that is called a low pressure, and the low pressure cylinder, that is the air it is coming from the sides, it is represented. And after the entering of the air through the pressure differential, air it is entering, where the low pressure compression it is done taking place, and after the discharging of the low pressure compressor, air it is going into the intercooler. This is the intercooling device where the cooling of the air it is done by the through medium, and after that when the temperature it is the cool down of the air to the original one, that is air is going into the second stage, that is the higher pressure cylinder, and after the compression in the higher pressure cylinder, air will be delivered into the outlet side. So this is the basic functioning of the multi-stage compression. High pressure required by the single stage, that is the require heavy working parts, has to accommodate high pressure ratio, increase the balancing problem, high torque fluctuation. These are the problem occurring in the single stage when the compression is taking of the high pressure ratio, require the heavy flywheel installation. That's why demanding of the multi-staging. This is the diagram where the air intake in the low pressure cylinder it is done. Intermediate pressure for the high pressure ratio will be generated as per the requirement. HP, that is the high pressure. Intercooler compressed air, it is cooled in between of the cylinders. That is the low pressure cylinder where the compression is done, starting of the compression done in the low pressure cylinder. High pressure IP cylinder, there will be a chances for the when the intercooling is completely done into the intercooler, air will be going to the intermediate cylinder where it will be compressed by the external sources, and the high pressure cylinder, after the intermediate cylinder, air will again pass it to the another intercooler, and after the intercooling, when the temperature of the air will be reduced and the air will be moved to the intercooler to the HP cylinder. So this is the functioning of the reciprocating compressor and the called a multi-staging. So perfect intercooling and the imperfect intercooling is describing here. For the perfect intercooling, when the temperature after the intercooler is reduce or return to the original temperature, that is called the perfect intercooling. And the without intercooling, the temperature after the intercooling of the air which is the more than the inlet temperature, that is called the without intercooling. It is depicted in the figure. The process 1 to 2, this is the compression of the air it is taking in the low pressure cylinder, and after the high pressure cylinder, their air will be forcefully delivered to the desired place. So single stage cycle, that is called a 18156. Without the intercooling, that is the low pressure 8147, and the high pressure, that is called a 7456. So 7456, that is the compression it is done in the high pressure, and the low pressure, that is called the 8147. With intercooling, this is the 8147. This is the low pressure, and the high pressure, that is called the 7.2. This is the actual condition, and the 3.6, that is the actual condition. It is depicted in the figure. For the saving of the work done because of the intercooling is done, and the exit of the air temperature from the intercooler, which will be equal to the air entering temperature. This is the called perfect intercooling. The perfect intercooling, after the initial compression in the LP cylinder, air is cooled in the intercooler to the original temperature before entering of the high pressure cylinder. Then the temperature T2 is equal to T1, or the points 1 are 2 are the same isothermal line. This is the perfect intercooling conditions. This is the ideal condition for the multi-stage compression, single-stage compressor, single-stage cycle 8156. But when the two-stage compression it is done, it is called a multi-staging, where the work done formula will be changed. For the single-stage cycle, the formula will be here 8156. This is a single-stage cycle. Work done is equal to n upon n minus 1 P1 V1 in the bracket of 1 minus of the P5 upon P1 to the power of n upon n minus 1, and the delivery temperature which will be calculated T5 is equal to T1 in the bracket of the P5 upon P1 to the power of n minus 1 by n. This is the delivery temperature. This is the two-stage compression without intercooling, and the with intercooling it is depicted in here. So without intercooling, low pressure cylinder, that is the 8147, and the high pressure 7456, discussed already earlier in the slides. Without intercooling, it will be depicted is here by the formula for the required work done for the with intercooling process n upon n minus 1 P1 V1 1 minus in the bracket of P4 by the P1 n upon n minus 1 plus n upon n minus 1 P4 V4 1 minus P5 by P4 to the power of n minus 1 by n. This is the same as that of the work done in the single stage. Delivery temperature also remains the same. This is called a without intercooling. The two-stage compressor with the perfect intercooling. With intercooling, it will be depicted as here, low pressure and the high pressure. 8147, that is 8 with intercooling in the done. But intercooling, it is done at the process in between of the low pressure and the high pressure. 72367, that is the compression and the work input, that is the required in the high pressure cylinder. The total formula for the work done n upon n minus 1 P1 V1 in the bracket of 1 minus of P4 by P1 to the power n minus 1 by n plus n upon n minus 1 P2 V2 in the bracket of 1 minus of the P3 by P2 n minus 1 by n. This is the formula for the work done. Delivery temperature, it will be calculated by this formula T3 is equal to T2 in the bracket of the P3 by P2 to the power of n minus 1 by n. It is the polytropic rule is equal to also written as the T1 because of the perfect intercooling is done. T2 is equal to T1 in the bracket of the P3 by the P2 to the power of n minus 1 by n. Because of the perfect intercooling, T2 is equal to T1. What is the performance of the reciprocating air compressor? Any type of the devices having the compressor just like efficiency. Similarly here, compressor performance is depicted by the formula of the efficiency. Isothermal power, we know that about the isothermal power. We know that because of the compression is done by the isothermal process also P1 V1 natural log of the P2 by P1 into the speed upon the 60 into 1000 kilowatt, and the isothermal work done per cycle, which is the depicted in the area of the PV diagram, which is called a P1 V1 natural log of the P2 by P1. Indicated power, which is the power obtained from the actual indicated diagram taken during a test on the compressor, that is the polytropic work done also. Compressor efficiency, it is equal to the ratio of the isothermal power to the indicated power. This is the two power ratio. It is called the compressor efficiency. Similarly, isothermal efficiency is the ratio of the isothermal power to the shaft power. And the shaft power, which is called the brake power required to the drive the compressor, this is called the shaft power. The performance of the reciprocating air compressor, just like efficiency, adiabatic efficiency, when the power is required to drive the compressor compared with the area of the hypothetical indicated diagram, assuming the adiabatic compression, that is called the adiabatic work done to the brake power required to the drive the compressor, where the gamma is replaced by the n. The total adiabatic work done, that is called the gamma upon gamma minus 1. It is represented in the formula P1 V1 in the bracket of 1 minus of the P2 by P1 to the power of gamma minus 1 by gamma. And the adiabatic efficiency, that is the area work done to the or adiabatic power to the brake power required to the drive the compressor, that is called the adiabatic efficiency. Mechanical efficiency, ratio of the mechanical output to the mechanical input, that is called the mechanical efficiency. Mechanical efficiency, the mechanical output, that is called the indicated power, and the mechanical input, that is called the shaft power. It is the ratio, and it is called a mechanical efficiency. How to increase the isothermal efficiency? By the spray injection manner, it will be increased by the object to cool the air for the next operation. And the what is the demerits for the, this is the process will be apply spray injection, require the special gear for the injection. Injected water interference with the cylinder lubrication. Third is the damage to the cylinder walls and the inlet and the exhaust valve. Water must be separated before the delivery of the air. These are the drawbacks for the injected of the water in the engine cylinder. So that's why the water jacketing can be followed for the saving of the compressor, circulating water around the cylinder to help for the cooling the air during the compression. How to increase thermal efficiency or the isothermal efficiency? It will be done by the intercooling method for high speed and the high pressure ratio compressor. Compress air from the earlier stage, which is the cool, to the original temperature before passing it to the next stage. By the using of the external fins for the small capacity compressor fins or the external surface, which are useful for the cooling purpose. Another last one method, that is called a cylinder proportion, that is called a short stroke, and the large bore provided much greater surface for the cooling purpose. Cylinder head surface, which is the far more effective than the barrel surface. So thank you. This is the today lecture. Tomorrow I will discuss the later class of the compressor.